Introducing Bourns' innovative GMOV Hybrid Overvoltage Protection Component, the first single-component solution to combine the technology of an MOV and GDT with flat technology. This presentation will discuss common weaknesses of MOV components and how GMOV technology effectively addresses them, becoming a superior solution to traditional MOVs. In addition, GMOV component construction details, operational characteristics, and target applications will be covered. Damaging transients on AC and DC power circuits can occur from any number of sources. The most common are due to lightning and switching transients. To counter the detrimental effects of transients, metal oxide varistors, or MOVs, are typically connected in AC circuits across a main supply in phase-to-neutral or phase-to-phase configurations to provide transient protection. For DC circuits, MOVs are connected positive to negative. MOVs are also used for maintaining DC voltage stabilization. While a new MOV is an outstanding transient overvoltage solution on its own, it will degrade over time from exposure to line voltage transients. Essentially, as the part ages, its maximum continuous operating voltage decreases. The normal failure mode for an MOV that has experienced long-term overvoltage exposure is excessive leakage, which leads to power dissipation and eventually can cause an over-temperature condition. Surge history, time, and temperature all contribute to increased leakage current, which can lead to thermal runaway that effectively ends the life of the component. In many cases, the end-of-life event can result in undesirable conditions such as fire and fragmentation of the MOV. Bourns has developed a breakthrough hybrid protection component that solves known premature degradation of discrete MOVs. The Bourns GMOV device combines Bourns' patented space-saving GDT with flat technology and an MOV, extending the operational life of the MOV by isolating it from line voltage, keeping it on call but not on duty, incorporating the best characteristics of each technology. The GMOV hybrid protection component attains its fully protective mode of operation after both devices have switched on. Under transient conditions, the GDT is always guaranteed to turn on first due to capacitive and resistive coupling. After GDT turn-on, voltage develops across the MOV, causing it to turn on and consequently clamp the remaining voltage. The GMOV component will reset itself after the transient current subsides and when the resistance of the MOV limits the follow-on current, allowing the GDT to switch off. The GMOV Hybrid Overvoltage Protection component has two key clamping characteristics: front protection level and clamping voltage, and is defined by their combination. Front protection level describes the very short duration it takes for the GDT to turn on under a transient condition. Clamping voltage describes the condition where both the GDT and MOV are in their fully conductive states. GMOV component features include its unique hybrid design, 14mm and 20mm sizes, voltage ratings from 45 VRMS to 320 VMRS, engineered MOV and GDT pairings, UL 1449 Issue 4 Type 5 recognition, and ROHS compliance. The benefits of these features include drop-in compatibility to standard MOVs, compact size, no current leakage, maximum current ratings of 6 kA and 10 kA, extended operational life of the MOV by isolating it from the voltage, in other words, on call but not on duty, reduced risk of thermal runaway, low capacitance, 4 picofarads, predictable failure mode, and temperature tolerance. As for target applications, reduced leakage current is appealing in Energy Star applications, especially in the presence of voltage stress. Reduced leakage current and constant capacitance of the GDT make it optimal for power line communications, and the capacitance level advantages achieved with GMOV components allow power line communications to achieve acceptably high data rates. Bourns GMOV hybrid overvoltage components achieve superior performance and reliability in AC to DC power applications requiring overvoltage protection. As a drop-in replacement for MOVs, GMOV components provide a direct protection solution that keeps design manufacturing changes to a minimum. The robustness of GMOV components, combined with their lower leakage current and reduced capacitance, deliver application advantages that other types of protection solutions cannot offer.